Hello and welcome back to Pure Science Education. Hope all is well. Today we're looking at going through paper 1 for chemistry, a quick whiz through in terms of revision. But as you can see, there are lots of different topics I'd like to cover today. So what we will need to do is make multiple videos. So you will have to go back and forth and check out all the different videos to follow. So the main topic in atomic structure and periodic table that I want to look at today is electronic configuration. So let's have a look at an example of electronic configuration. Electronic configuration has got a bus rule, which means in the first shell, a maximum number of electrons you can have is 2. The second shell is 8, third is 8, and then the fourth is 2. Now, this quite nicely fits in with the pattern for GCSEs, which is hydrogen to calcium, 1 to 20 electrons. However, in the A level, there is a slightly different pattern and this rule doesn't apply. So in terms of GCSE, we're quite happy with that. Now, how does the group number relate to electronic structures? And the answer is the group number, it relates to the number of the electrons that are in the outer shell. So if you're really confused in an exam scenario and you're not quite sure what's going on or how to do electronic configuration, look at the number of electrons in the group that you have the element for. That's how many electrons you should end up in the outer shell. If you have more or less, that means you have missed something out. Let's look at the first one here, lithium. So lithium has got 3 electrons. So electronic configuration of 2, 1. So in the first shell, like I said, you can only have 2 electrons. Make sure you draw the electrons on the shell, not outside the shell and so on. And then 1 electron in the outer shell. So lithium belongs to group 1. So you will see that I've ended up with 1 electron in the outer shell. You then got Be, beryllium. So this time I have 2 electron in the first shell. So this is here. The comma here represents the second shell and I have 2 electrons in the outer shell, which means it belongs to group 2. Going back to group 1, sodium, I have 2 and then 8. Now see how I always draw electrons because I draw them in pairs on the shell. So make sure when you draw these electrons they are in pairs. That's where you can't go wrong unless you draw in a single electron, which will be on its 1. So again, sodium belongs to group 1. It proves that because it's got 1 electron in the outer shell. Now magnesium, 12 electrons, 2. Then we got 8. If you draw in pairs, you can't go wrong for pairs of 8. And then 2, 4, 6, 8, and then finally I got 2. Again, magnesium is in group 2 of the periodic table, and so on. You then got neon 2 and 5, carbon 2 and 4, and so on. So each one of these you can draw and practice when we post the video. I'm going to leave the rest blank for you to have a go. This will be a good practice for you to use the shells that have been given to you and electronic configuration to draw them in the correct order. Lots of students gets really confused, so they draw them in random order and all sorts of places. So please have a go at them when you get the video. The next topic, in terms of periodic table, I wanted to look at today was in terms of the discovery of the periodic table. This is quite a common question that comes up at GCSE and A level, and we're going to look at what these answers are. So, a tiny sphere that could not be divided. That was discovered in the 1800s. 1890s, electron discovery plum pudding model. We then got 1908 to 1913. We got the alpha scattering particle. Find out charged nucleus. 1914, electron orbiting in a specific distance in energy shells. Later on, we got positive charged nucleus. And 1932, the final one. So let's have a look at what these mean to you. So, first one, John Dalton was the one who discovered tiny sphere that could not be divided. We then had in 1890s, J.J. Thomson, electron discovery. He discovered the plum pudding model. where he discovered that if you imagine you had a pudding, in the pudding on the top you had positive and negative charge as your plums and puddings. So the sphere was all positive, with the negative electrons being the plums around going around it. So you then had the alpha scattering model, which proved J.J. Thomson's model wrong because he had fired some alpha particles, and rather than getting absorbed, they got deflected back, which then proved there was more to the model of the atom. We then had 1914, another discovery being made, and this time we had Bohr model. Now, Bohr model is the model that you use in today's world at GCSE as well as A level. So, in a Bohr model, you have in the middle the nucleus, which is made up of proton and neutrons. You then have on the shells, on different energy shells, the electron that surrounds the nucleus, where the electrons orbit. You then later on discovered a positive charge of the nucleus, which then could be subdivided, and that was called a proton. And finally, in 1932, James Chadwick proved that the neutrons did exist. So we now come up with the whole model of where we have protons and neutrons in the middle of the atom, and we have electrons going around in the orbit. So that was a quick snapshot through to electronic configuration and the discovery of periodic table, which are the two key topics that come up as topic 1. Now we're going to move on to bonding topic, which is quite lengthy, but I've covered it all in one slide. So we're just going to take our time to go through each one. So if you look at ionic bonding, this happens between a metal and a something. The reason they are so strong is because they have something charges. So a lot of students get confused between ionic and covalent bonding. Now the best way to learn this is ionic bonding is to look at the keyword ionic. And if I look at ionic, I can see that I need to form ions in order for this to work. So ion is when you have lost or gained an electron. So this bonding takes place between a metal and a non-metal. The reason why they're so strong, because they have opposite charges. And if an atom loses an electron, it gets a positive charge, and if an atom gains, it gets a negative charge. So just concentrating on this box here. So if, as it says, if something is in the metal, it's lost an electron, it gets a positive charge, and a non-metal gets a negative because it tends to gain electron. So if you look at the structure of the periodic table, mainly group 1, 2 transition metals, and 3 have positive charge because they tend to lose electrons to get a stable outer shell configuration. And if you then look at 5, 6, and 7, they tend to be negatively charged because they tend to gain electrons to get full shell outer configuration. So that was your ionic bonding. We go to the simple covalent bonding. Covalent bonding happens this time between a non-metal and a non-metal. And the key here is that they share in electrons. So they don't lose or gain, they just share. Most covalent bonds are oxygen and water, are gases and liquids at room temperature. Another key feature of covalent bonding. This time the bonding is weak, but although the covalent bonding is strong. So the bonding between the molecules are weak. The larger the mass of the covalent molecule, the higher the melting and boiling point, because it's going to have a strong chain. Need to put in a lot of energy to break that. So in terms of giant ionic structures, we're looking at this structure here of salt, of NaCl. So if you imagine Na is the green spherical ball, and Cl is the purple ball here, the positive and negative. So Na has a negative charge, chlorine has a Na has a positive charge, chlorine has a negative charge, and they're nicely arranged in a given lattice structure. So you just have arrangement of positive and negative charges, and this arrangement is called a lattice. They have very high melting and boiling point because of the strong positive and negative ionic bonding, and they conduct electricity if dissolved in water because the structure breaks up, um, or if it's molten, if it's been melted. You then go to the giant covalent bonding, and the examples you need for GCSE is diamond, graphite, and silicon dioxide. They all have giant covalent bonding. Now this is slightly different to the simple covalent bonding because the molecule is much bigger. It has stronger bonds between the molecules. So diamond, for example, all four covalently bonded structure with high melting and boiling point. However, diamond doesn't conduct electricity because it doesn't have free flowing electron, as four bonds are full. If you then look at graphite, graphite is soft with weak intermolecular forces. It's in layers and they're hexagonal in shape. The reason why you can write with a pencil, which is graphite, is because it's got three carbon bonds that are bonded and one that is delocalized. So only three bonds are in a fixed position. Graphite also conducts electricity because it's got the delocalized electron, the fourth one, which is not bonded, which is not in a given position. And then finally, we have something called a metallic bonding. Now, metallic bonding takes place within metals, which are called sea of electrons. Metals tend to lose electrons and gain a positive charge. And these electrons are being lost, like I said, in terms of sea of electrons. So depending on what metal you have, that's the charge you'll have on this sea of electron diagram. They tend to have a high melting and boiling point. They are ductile and malleable, which means they can be pulled into wires or put into different shapes. So I'm going to stop here for now for this session, and then we'll continue in the next video with revision on paper 1 for chemistry. I hope you can join me for the next session. Thank you.